Thank you. It works, yes. My favorite part of speaking here is always that without having to say anything, you get an applause, which is great. So hello. Yes, very good. Hello. Welcome, everybody. So I'll be talking about something about Micropython, which basically is a project that wants to bring Python to the microcontrollers, really. So a little bit about me. Beck already did a good job of introducing me, but I co-founded Exciting, which is very exciting, which is part of Media2B. We built the Internet of Things, and I am a software guy. So, Micropython, who of you have heard of it before? That's very good. Who used it before? Yeah, very good. For something serious, well, I suppose so. For something that is running right now, I guess no one. No, that's okay. So, if you said no, what is Micropython? Well, basically what it says up there, lean and very fast. The fast part is a bit exaggerated, maybe, but it's okay. It was kickstarted in November 2013 by this guy, Damien George, who is a theoretical physicist. He wanted to try some things out on physical hardware, but he didn't like C and Lua so much, so he decided to just port Python, which is a good idea. These are some other things that happened in 2013, which we will not be talking about today. Only the last one, it was not exaggerated. So the original Kickstarter ended in 2015. The code was made open source, and initially it was delivered together with a Pi board, which is just a microcontroller, but now it runs on multiple chips and is ready to be ported to more chips, basically. So why would you do this? Well, that's a stupid question, because of course you should. Python is a great language. Zoidberg makes a good point, because why not? But this is actually really why it's a good idea to port Python. There's an existing community, which is all of you, I suppose. It's easy to learn, as we all know, and also it's really well suited for development on embedded systems, actually, because of the bitwise operations and a good separation between ints and floats, which is what JavaScript and Lua, two other languages that are being ported to the embedded world, kind of lack right now. It's really good for rapid prototyping, which you already see in many other places, of course. And it bridges the web world with the IoT world. Python is, of course, used in many more places than only the web world, but the web world is a bit far away from the embedded world sometimes. And Python offers a lot of opportunities for optimization because it is, well, there's a decent, how to say it? It's also a compiled language, of course. So compiler tricks, compiler optimizations also apply here, which we'll mention in a little bit. The question, of course, why not just use CPython and try to port that to embedded controllers? Well, it's mainly because of the RAM usage. CPython is not very conservative about RAM usage. These are some examples. Just by booting up, CPython already pre-allocates 257 positive integers and 5 negative integers, which basically gives already reserves 4K of RAM. If you're on a microcontroller with 8K of RAM, you're kind of screwed. And method calls are quite inefficient. Well, not so much inefficient, but that they allocate memory on the heap. For example, let.on, it creates a bound method object on the heap, which means you're already wasting RAM. And again, on microcontroller world, you don't have so much. And especially something like let.on, you will run in a loop. So you'll call it thousands of times. You cannot have it like this. So what is Micropython? It's Python. Yes, no shock and awe. It's about 3.4, so you do have to put brackets around the print statements. You have your with operator and, well, basically everything that you expect from Python. But, well, not everything, of course. One of the things they did to reduce code size is just to remove extra libraries, such as functools. And even this, which is really a pity, because it doesn't take up too much space, but still it takes up some space, of course. So it has at least sys struct machine and MicroPython being the internals, of course, and specific ports to specific boards, provide specific hooks and other custom modules depending on the manufacturer. Oh, and also they have async keywords, which is nice, because that's kind of a 3.5, Python 3.5 thing in there. The theoretical minimum system requirements are 128 KB of ROM and 8 KB of RAM, after subtracting all other software, which is very, very, very small. Especially some people who were in the start of home computing can remember that this is not very much to work with. The reference implementation is, as mentioned before, the Pi board, which runs on 1 MB of flash and 192 KB of RAM, which is quite a bit more sizable. There's also Unix port, which uses about 280 KB of flash. I couldn't dig up the amount of RAM usage, and I didn't measure it myself. There's also an external standard library, which is written in Python. You install it with a tool called upip, Micropython. Basically, it's all written in Python, so we don't have to write C. And it works pretty well. So then the question, of course, how did they make it so micro? Well, the main thing is RAM optimizations, as I kind of hinted at before. And these are a few tricks that they did. One of these things are the predefining of strings in the ROM, like let, on, and read, so they never have to actually allocate any space on the heap to use those things. They also optimize method calls. I'm not sure if any of you is familiar with how PyPy did it, but that's basically the same thing. And basically everything that can be in ROM, so read-only memory, is in the ROM. He tries to put as much there as possible. And for example, the garbage collection, they don't use any reference counts. It's just a naive mark and sweep. So that also saves per object a byte. One example of things that they did is tagged pointers, which is basically trying to stuff integers and strings in pointers to avoid having to allocate again RAM on the heap. So an integer, for example, is a pointer with as the last bit set 1, so then it identifies as an integer, and the rest of the bits are basically set to the value of the integer. So the number 1 is actually the binary number 3 here, which is a neat trick. Nothing new, actually, because all these compile optimizations, they basically just exist, and you can read them in a book, but he actually applied them in something real, which is great. So, demo time. I wanted to show a few things. I ordered a nice LED thing and some other things to show something on here, but of course I was cheap and I ordered it in China and it didn't arrive yet. So that's what happens always. Luckily someone put a webcam on front of his PyBoard and some LEDs on it, so I'm going to show a few things there, just a few silly things. Like here below is the code. Let me see here. So if you run this, basically the LED will go on. There, it went on. It's great. It works. It wasn't a lie. Let's see. Some other small thing that we can do is import pip. LCD is pip.lcd. Yes. LCD.light. There's actually some background music. I didn't hear that. Hello, pyGrunn. Did I match up properly everything? Oh, it works. This is awesome. Very good. I also have brought a small microcontroller, this guy. This is the Huza Feather, which is ESP8266. It has such a chip. Let's see what happens when we actually connect to it. Let me just reset it. Well, it couldn't read some files, but there's actually Micropython on there. Let me see what I was going to show. So we have a few things. We have pip here. Pip is the... Oh, we don't have it yet anymore. I updated it the other day. Well, that's OK. We do have GC, though. And GC is the garbage collector. We can see how much memory we have, which is really not so much. So after allocating some stuff, I basically have less. I can disable it, of course, and I can also just allocate too much, and it will tell me the same thing. Basically say that I cannot do all these things that I'm trying to do with it. So we had time as well, and time when, we have local time. Although this guy has no clock, so it just defaults to starting from the year 2000. We can, of course, import sys, and to prove that it's actually running on. It's 3.4, so you can see that. Let's see, we have OS. We can also read and write from the file system. Of course, just like Python. So it's basically Python, which is, in certain sense, not such a big deal, but it's quite nice that it's running on this small thing. Because we can also do things like see the frequency of the machine and then overclock. Too many zeros. Yes, there we go. So I overclocked it. This is great. Now it's getting really warm over here. So there's also some network support, which I'm not going to show right now. You can even configure it to work as an access point, which is nice. This guy has not much use to function as an access point, I suppose. But we also have something strange that they just now implemented is a web REPL. Although I don't think I'm on the same network as this thing. But basically what they did is they implemented a REPL on the web, which should run on here by standard. Which you can use to just see the REPL on the thing, which is a little bit silly because it works with WebSockets and everything, just on this tiny thing, which is funny. Anyway, back to the presentation, wherever I did leave it. Right here. So a few of the hardware features that it offers. There we go. You can disable interrupts, you can trigger and disable the garbage collector, as we saw already. You can write inline assembler and emit bytecode or machine code. So here's inline assembler, because, well, finally you have Python and microcontroller, so you're going to write assembler. Well, of course, it's very useful to optimize parts of your code. They use the thumb set of assembler. You can also have native, which basically means you write more or less just Python without with context statement, which is twice as fast but a larger binary, so it can be used if you have a large ROM and need some more speed. And also something like Viper, which is now called Xerinth and is something enterprisey, which is really weird. But I just wanted to show it because you can use type hints, which makes it even faster. A few supported boards that I want to mention. So we already saw the Pi board before, which was the original reference implementation, which has an accelerometer, a few LEDs, 30 GPO pins. And the microbit, which was already mentioned by Berko before, which is actually really interesting. It's a really tiny implementation, but it's supplied to 1 million school children in the UK, which is pretty huge. All of the kids of 12 years old, they get one of these things. And they basically will be playing around with Python and some kind of graphical development interface, which is developed by Microsoft. So that's probably a great alternative. Well, but it's a really fun project, and I really think it's a good idea to have a look at it because it's could be the future of programming education for kids. It comes with, as I said, a Python editor, drag and drop interface as well, but also a mobile app to upload code, which is very nifty, and tons of documentation and teaching material, etc. There's also the WiFi, which is more of a, how to say it, more a professional grade board. They also offer a bunch of extra libraries, for example, integration with Blink. Blink is a way to communicate with your Android app or iOS apps, but also for MQTT or for URLlib and OneWire. And well, it's also a little bit more sizable, so it's really good for your own projects. But they actually, they say it's small and light to fit in any cavity, which is very weird to me, but anyway. It's a decent way to introduce these things, I suppose. There's also LowPy, which is basically like the WiFi, developed by the same company as the WiFi, but with LoRa and Bluetooth, actually. I'm not sure if you're familiar with LoRa. Very good. Then there are a bunch of you. LoRa is a wide area network which is already running here in Groningen. It's actually it's a protocol, but there's the Things network, which is an open source an open network, and crowd-funded network as well, which allows you to connect your devices over ranges of 1 or 2 kilometers with very low speed, of course. But it really more defines the Internet of Things. And it also runs on the ESP8266 chips, which is like this guy, basically. The current state of Micropython. So we have one full-time developer, which was this Damien George, and 2 core contributors in total, including this Damien George. It's partly funded by European Space Agency. That's why the one full-time developer can be full-time. They want to focus on robustness and determinism of the virtual machine. Because they actually want to bring it into space, which is very cool. They did a Kickstart in May 2016 for proper support for the ESP8266. So they're not completely done with it, otherwise I could have shown it right now. And it really feels like it's maturing. It's still a bit early days. You still have to compile everything yourself, but that's kind of part of the experience of embedded computing, of course. But it actually works, and there's not many bugs or anything like that. Not at all, I haven't found any, so it's very good. So, well, the question is it production ready? It kind of depends on your board. Because different manufacturers have different ports and they test it differently, of course. I think the WiFi is doing actually pretty good. The microbit is also very good. And in general, Python is just amazing for prototyping, and especially Micropython in this case will help you a lot on there as well. But also a funny idea is to embed it in games and apps. Basically what Lua does now. So if you really like Lua and tables, you should use Lua. But you could also use Python to embed it into your game or app. So summary, we have Python on my controller and it works. And here's an image of a very small Python, which I had to put in there somewhere. Thank you. I blasted through it a little bit faster than I thought, but that gives us more time for questions, I suppose. Yes.
1 second.
Yeah.
Do you know if there's a version that runs on the Raspberry Pi Zero?
I'm quite sure there's not. But, well, I'm not completely familiar with Raspberry Pi Zero, but does it run Linux? Yeah, then there is, yes. Of course it runs Linux, it's a Raspberry Pi after all. But there's a Unix port which is very tiny, so that should be fine, yes.
Does it need Linux to run, or is there a native port to the hardware?
For Micropython, no, there's no native port yet. For the Raspberry Pi Zero, not that I've seen at least, but I'm pretty sure they're working on it, because they really like to. More questions?
More questions? I have an extra question. I'm interested in the BBC handed it out to 1 million children in the UK. Are there any projects that you know that they've built with it, or how long has it been? How long ago did they do that?
Well, there's this one thing that they made was like a truth or dare game, which is basically like a small robot where you, because also the microbit comes with these extension boards that make it easy to control servos and stuff like that. So they have this small robot which you just plug in the microbit, and it's for kids. So you press the button. It has a few buttons, and you say truth or dare. You throw it, and it drives around, and it picks the person who, well, it picks a random person, and then it shows if it's truth or dare after clicking the button, which is kind of silly, I guess, but it's a really nice thing for kids to play with technology and to see how it works. So well, that's one thing. Well, and basically what's really interesting about it is that it comes with a lot of teaching materials. So there's a lot of examples and development tools and stuff. I guess there's another question.
Yes. Did you deliver already any projects using Micropython?
No, not yet. Not yet. No, it's very early, and to do that, I would like to have a Wi-Fi board, but it was out of stock recently. This guy is well, just an ESP chip, and they've just started socket implementation. What we do normally is at least something with the internet and connectivity. And the old, or the existing implementation for networks was with callbacks and stuff. And if I wanted to do callbacks, I was going to do JavaScript. So no, I didn't use it yet for any real project. Yeah.
One thing I like about the project, I've dove a little bit into it, it was that it's very well taken care of because it was handed out to 1 million children. The documentation and the editors, everything is very well, it's very solid. So if you want to learn kids how to program, well, IoT devices, this is one of the best options to get them started with these things.
For sure.
The documentation is great. And also, it's very nice for the English, I think, the English Python community. I mean, I can imagine that the PyGrunn from England will be pretty huge in 10 years' time.
You would expect so, yes. Yeah. It would be very nice, at least, yes.
Yeah. Any more questions? Yes?
So what kind of batteries do you need, and how long can it run without?
What kind of batteries?
What kind of batteries, yes.
Well, that depends on your application and your well, what you want to do with it, basically, and what your program does. as always. Basically, it takes up really little bit of memory footprint, so it can be used for very low battery usage things. This LowPy especially was made for that, because LoRa also is a protocol which is designed to use as little battery as possible. So yeah, it's quite suitable for using it with low power devices. Yeah. No bottleneck.
Hello.
Hi.
You showed a few nice boards. Are there some other boards in the pipeline coming up?
Well, I believe that this guy wasn't actually delivered yet. So this is one of the ones that is coming up. Well, there are quite a collection, but I think these are the most professional, most marketed ones. I'm sure there are others that are working on it, but yeah, well, it depends also on the marketing budget, of course, how much people know about it. But yeah.
And any companies that are working on this? I mean, besides the BBC?
Well, the ESA, which is really funny because I just found out about it earlier this week. That the European Space Agency is, of course, full of people who also who need to write software for embedded systems, and they are working together with this guy, this Damien George, to make it a more professional and more robust system. So, well, that's quite kind of a professional company that's working with it, at least. Yeah.
Questions left? Going once? There you go.
Does Micropython include some libraries to access your Wi-Fi capabilities of the board?
Yes, for sure. Should I maybe just show that? Let me see. So this is that board that I had just now. So we have here network. This ESP board, for those not familiar with it, basically the whole goal of the ESP thing is that it has Wi-Fi and is cheap. So we can see here that it's not active, but we can make it active, because if I do that, it will crash. Yes, so I can scan. Takes a little while, but let's see if I can connect to something. What is an open one? Cell 2 was, I heard that the first. Yes, the password is probably empty. Now, is it connected? Oh, well, there we go. Hey, brackets. Which is great, because it works. Oh, it's actually and this other thing that I like always to do is make it an access point. Is Micropython says hi to pyGrunn. Oh, I suppose it doesn't work with the new version anymore. Well, that's okay. Anyway, you could make an access point out of it. And it also had, for your question, the network connectivity. I think there was the socket, but I just have to figure out how that works again. You can basically make a socket. Oh. Ah, yes. And you can say something like connect, after which you need to send and receive. Basically, it's a bit of a dance now, because you don't have requests yet, but that's just a matter of time.
Thanks.
Yeah, no problem.
So if you disable things like garbage collection, is it possible to use it in a sort of real-time mode?
Sure, yeah, no problem.
So you can do real-time programming?
That's the idea of it, yes.
Okay.
Yes.
Yeah, yeah.
Well, especially if you use this thing called Viper, but I didn't dive into it much, because Viper is Python embedded in real time. But I didn't dive into it because the documentation was all removed and put behind, like we have this big enterprise library which you should purchase from us. So I couldn't figure out that exactly more. But yes, if you disable garbage collection, because you can also disable interrupts, you can basically control everything on the hardware, which should allow you to do real-time programming, yes.
Right, and then you cannot do things like wireless and...
Basically, no.
Yeah, right.
You probably shouldn't want to do that.
Okay, yeah.
There's another one here.
Can you install eggs or wheels from PyPI, or is there something similar?
Yes, you can. Maybe I can just show that as well. It's not that easy to get out of here. So I have here the Unix port of Micropython. So what I can do is something like this. But you can. I didn't actually try to install the things like requests or something. I'm not sure what would happen. Which is that. Makes sense. But you can install specific libraries that are for it, which start with Micropython, like functools or like, well, give me an example. Anyone have something? urllib, which should work. And then you can, you have urllib, which I just hosted on PyPy. I forgot the bracket. It's not called a bracket, actually, is it? Well, it actually doesn't have much, but there is a standard external standard library on GitHub, which is all written in Python, which you can. They're also on PyPy as well, so you can install them basically like this.
Last question, anybody? I also like to thank Lars for an excellent presentation. Thank you very much. Again.
Thank you.